In this video, we're going to be talking about using the multimeter to measure current and resistance. We already talked about what multimeters look like and what probes you use with them in the voltage measurements video. This slide is just a reminder that these are the kind of multimeters that you're likely to find in the labs at MUD. We've already talked about taking voltage measurements with the Elenco. It can also take current measurements. To take them, you use the COM plug and the two current plugs that are highlighted in yellow over here. You pick which current plug to use based on the amount of current you expect to measure. One of these is suitable for very high currents, like 10 amps, and the other is suitable for lower currents, on the order of milliamps. The milliamps plug has a really delicate fuse inside of it, so you need to make sure that you only put milliamps through that terminal, or you'll blow the fuse, or worse. Just like voltage measurements, you can use this button to pick whether you're taking an AC or a DC measurement, and you use this knob setting in order to pick what range of current you're trying to measure. We've already talked about taking voltage measurements with the Elenco. It can also take current measurements. To take them, you use the COM plug and the two current plugs that are highlighted in yellow over here. You pick which current plug to use based on the amount of current you expect to measure. One of these is suitable for very high currents, like 10 amps, and the other is suitable for lower currents, on the order of milliamps. The milliamps plug has a really delicate fuse inside of it, so you need to make sure that you only put milliamps through that terminal, or you'll blow the fuse, or worse. Just like voltage measurements, you can use this button, whether you're taking an AC or a DC measurement, and you use this knob setting in order to pick what range of current you're trying to measure. You measure resistance by plugging your probes into the volts-ohms plug and the COM plug. Just like current and voltage, you have to pick a range of resistance that you intend to measure. There are two special ranges on here. One of them is at the very bottom, this little sound wave. I refer to that as beep mode, and it's a helpful tool that will make the multimeter produce a noise whenever it detects a low resistance. So it's useful for checking connectivity and detecting shorts and stuff like that. And it defines a low resistance as less than 100 ohms, which is useful for measuring the forward drop across diodes, but we don't use that a lot in the 80. Next, we want to think about how the current mode multimeter fits into our big ideas of circuit measurement. The equivalent circuit mode for a current mode multimeter is a very small resistance, this 10 ohm thing that you see here. Current measurements work by sticking a small resistor in series with the circuit that you want to measure, so your circuit under test up here, and then they observe the voltage across the little sense resistor. If the resistance were large instead of being small, it would develop a large voltage across itself based on the current that you were measuring, and that would mess up the circuit under test. So the input resistance for this mode has to be really tiny. But the problem is if you put a voltage across a small resistor, you wind up with a lot of current and in turn a lot of power. So that's why the current mode circuitry is so much more delicate than the voltage mode circuitry, and why I made a big deal about the fuse on the last slide. Although there's kind of an implicit voltage measurement taken in order to figure out what the current is, which I've indicated here, we don't usually think of current measurements as being referenced anywhere because they're placed in series with other stuff. We only care about how much current is flowing through them, not what 2 points they're hooked between. So you can safely insert the multimeter in series with just about any circuit and measure the current. The problem is if you accidentally forget you're in current mode and put it in parallel with a circuit, then you've just created a short circuit around your circuit under test, and that usually blows up the multimeter. Be really mindful to put your current mode multimeters in series with your circuits and not in parallel. The equivalent circuit for resistance mode is a big resistor, just like the voltage mode measurements. The only difference is that in order to measure a resistance, your multimeter needs to actually supply power to the external circuit. This measurement works by shooting a little bit of current out through your terminals into the world and observing how much voltage develops across the multimeter as a result. Because it knows how much current it's sent, it can relate the voltage it observes to the resistance out in the world. Because you want all your current to go into your circuit under test and not your multimeter, you use really big input resistance on your multimeter again, so that's the 10 mega ohm resistor that's pictured in this figure, just like for a voltage measurement. And that should reduce the loading effects of your measurement circuit on most small resistors. Though, if you were to try to measure a 100 mega ohm resistor with this circuit, you'd run into problems because the multimeter actually has a smaller impedance than that. Now, one consequence of this type of measurement is that the multimeter actually provides a small amount of power when it's taking a resistance measurement, and that can inadvertently turn on chips on your circuit board, which will give you really weird results. So if you see a few hundred kilo ohms when you expect an open circuit, it's probably just some chips starting to turn on because of this current source. So to summarize the main points of this video, current measurements on a multimeter require you to use special plugs, and they also require that your multimeter is connected in series with your measurement instead of in parallel. And that's because current measurements are especially sensitive, and you want to be really mindful to make sure that you only put small currents through the multimeter when you're measuring low range currents. They're range sensitive because the current measurement equivalent circuit is just a small resistor. And then changing gears briefly, Resistance measurements are interesting, but you have to remember that they can accidentally turn on circuits which will give you spurious results.